Hello everyone, today I'm gonna talk about basic principles of Docker and what Docker consists of and why would we use Docker instead of virtual machines sometimes. So let's start with comparison of Docker and container and virtual machine. So virtual machines take up a lot of storage and RAM, and they are timely to set up and more difficult to manage, which is, I think it's a very big disadvantage of virtual machine. Sometimes it's a good thing because when you have the entire operation system, it allows you to run multiple services in the same virtual machine, which is sometimes really desirable when the services are tightly coupled or for example they share the same data sets. A Docker instance doesn't host the whole operation system. It hosts only a part of it, just a really core part that is required to run your specific program or service. The very good thing that with Docker you can abstract away all the timely configuration and environment setups and focus on the coding instead. And even bigger advantage of container is that it provides a homogeneous environment, and instead of having to install a list of different dependencies to run your application, now all you need is to install a Docker. And Docker is cross-platform, and every single developer in your team will be working in the exact same environment. So let's talk about what is the main purpose of Docker. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. And you get a significant reduce of the delay between writing code and running it in production. So let's talk about Docker Engine. Docker Engine is like another word for Docker, which you can come across. And so Docker Engine is just a client-server application with these three major components you can see on the image. There is a server itself, which is a type of long-running program called a daemon process, which is running in the background, and it's not under our control. So another layer is a REST API, which specifies interfaces that programs can use to talk to the daemon and instruct it what to do, and a command line interface. So CLI, it's a client, and we will talk about it a bit later. So what Docker consists of? I would say it's four large parts. One of the first part I'm gonna start with is a docker-daemon. So you can see it over here on the picture, and daemon starts on a host machine. So a user does not interact with a server directly, right? He uses a client for this purpose. This is what we developers actually use. This is our interface. So you can see the client over here, we use command line interface, but we doesn't directly interact with docker-daemon, with a server part. Another thing, another main thing is image. Image is a very important concept. It's actually a read-only template, and it's the basis of the basis of image is something like operation system. It doesn't technically correct, but I'm used to think about image like about crippled version of operation system. And this operation system, this crippled operation system, this image, has only minimal functionality. For example, like we have only operation system kernel and maybe something on top of the kernel, but definitely no user interface. So it's like a crippled version of operation system. Another way how you can think about image, that an image is a serialized copy of the entire state of operation system. I'm gonna remind you what serialization is. This concept is used in a lot of programming languages and programming concepts in general. So serialization is a process of translation into a format that can be stored and reconstructed later. For example, settings of application are stored in serialized format, or we can store it in bytecode, and having this bytecode, we can restore initial data. Another example: when we play a video game, and we decided to save our progress and leave the game. The entire world in our settings are serialized. The state of all objects in this world, in the game, in the game world, is serialized into the specific format. So all settings, all entire state of the whole game is serialized into the specific format when you save the game. And when you load the game, we found ourselves at the same point where we left the game, and we found out the entire state of the whole world is the same. Image is serialized copy of the entire state of operation system. So it's like with video game example I've told you. So the first thing to realize is that the software to be loaded into the machine, and image is actually a piece of software. So the software to be loaded into the machine exists as a collection of bits on some media. And when it boots, the boot process can treat these bits as a data stream, which could be a set of instructions, data, an address, anything. It's just a data stream. And another good thing, you can think about image like about a snapshot. So imagine that when we save an image, we make a snapshot. So the snapshot is a state of a system at a particular point in time. It can refer to an actual copy of the state of the system. As a consequence, everyone has the same copy, the same environment. And these images are used to create containers. We cannot change the image at all. This is another very important point in the Docker philosophy of Docker. We cannot change the image at all. All we can do is to make changes and save everything as a new image. In other words, all we can do is to make a new image on the foundation of the old one. Docker enables to easily create new images. And besides, you can download images made by other people. So we are at the point of another main part of Docker is registry. You can see it right here on the picture. So it can take a registry actually is a place where all images live. The official registry is a Docker hub. So it's like GitHub. I mean the concept. GitHub is for code. You can share code, upload, download code of other people. And Docker Hub is for images, but the logic is pretty much the same. You can find a lot of images that you can download and run. When we share our registry, and anyone can run it, and this is one of the main purposes of a Docker. Another main concept of Docker, of course, are containers. It's a thing why Docker exists. A container contains everything that is required to work with an application. Each container is created from an image. Containers could be created, changed, started, transferred to another host. Each container is isolated, and in fact, a container, as I said before, is a homogeneous environment for running an application. So it was the main principles of the Docker, and another thing I would just add another important thing about images. We need so as I said, we need an image to create a container from it, and each image consists of a set of levels. This is one of the reasons why Docker is so lightweight. So you can see on this picture the container, which actually is a set of layers. So let's consider one of the use cases. You need to, for example, you need to update an application, right? And Docker creates a new level for this change without restarting of application or replacing the existing image. If you use virtual machine, you will replace an image and rebuild this application if you put some changes into it. And another great thing is that you don't need to share the new image when you make an update. All you need is to share this new update only, and the whole image will stay exactly the same. So guys, this was a video about Docker concepts. I hope you enjoyed it. So thank you very much for watching.